Chapter 1.4, exercises 11 through 22, page 124. In this section of the exercise, we're going to be working on finding compositions of functions. And in exercise 11 to 14, find f of g of 3 and g of f of negative 2. Well, the first thing we're going to do in this one, f of g of 3, is we're going to find g of 3. Well, g of 3 is equal to 3 plus 1, which equals 4. And now f of g of 3 is going to be f of g of 3 is going to be the same as f of 4. Why do we know that? It's because we plugged in 3 for g and found 4. So we're going to have 2 times 4 minus 3, which equals 8 minus 3, which equals 5. So we summarize f of g of 3 is equal to 5. Now we're going to go ahead and find g of f of negative 2. Well, f of negative 2 is going to be equal to 2 times negative 2 minus 3. So that's going to be equal to negative 4 minus 3, which equals negative 7. And then we're going to find f of, let me write this, g of f of negative 2 is equal to g of 7, of negative 7. How do we know that? Because we plugged in negative 2 into f already. So we plugged in negative 2 into f, and that's going to be equal to, we plug in, we have negative 7 plus 1, which equals negative 6. So that's going to be, summarizing, g of f of negative 2 is equal to negative 6. So we have these two answers, and there they are, boxed in. Next, problem 13. We have the same thing for the same things, f of g of 3 and g of f of negative 2. This time we have the functions f of x equals x squared plus 4 and g of x equals the square root of quantity x plus 1. We're going to find f of g of 3, and the first thing we're going to do to find that is we're going to find g of 3, and g of 3 is going to be equal to square root of quantity 3 plus 1, which is the square root of 4, which equals 2. And so we now know that f of g of 3 is equal to f of 2. Why do we know that? Because we know that g of 3 is 2. So we did the g part first, and that's going to be equal to, we go in the f portion, we have 2, replacing this x here, squared, plus 4, which equals 8. So summarize, we say f of g of 3 is equal to 8. Next, we're going to look at g of f of negative 2. Well, first of all, to do this, we're going to say f of negative 2 is equal to, we're going to plug in negative 2. And one crucial thing I'm doing here is I'm putting this negative 2 in parentheses. So we take negative 2. If we just put negative 2 squared, we're going to get 0, I believe. Anyway, we get negative 2 squared. That's going to be 4 plus 4, which equals 8. So g of negative 2 is, let me rewrite that. G of f of negative 2 is equal to g of 8, which equals, okay, we go into the g, we put in square root of quantity 8 plus 1, which is the square root of 9, which is 3. So to summarize, we say g of f of negative 2 is equal to 3. So we have our two sets of answers. And we go on to next on to problem 15. In exercises 15 through 22, find f of g of x and g of f of x. State the domain of each. And the purpose of this exercise is the standards of learning here are to know and understand that in composition functions, g of f of x is not necessarily the same as f of g of x. So in composition functions, order matters. So first we're going to do f of g of x, and we're going to, for that, plug this g of x into the f. So we're going to take this g here and plug this any place we see x in the f. So f of g of x is equal to 3 times, let's plug in g of x, which is 20x minus 1, and plus 2. So everything in f of x we've left the same, except we replaced x with this x minus 1. And simplifying out and expanding, we have, using the distributive property, we have 3x, and 3 times negative 1 is minus 3 plus 2. So f of g of x is equal to, let's see, negative 3 plus 2 is minus 1. So 3x minus 1. And for domain, we look at primarily, the first thing we look at is our original. Are there any restrictions in the original functions? No, there are not. And so our domain is going to be, we have greater than negative infinity, less than infinity. So that's going to be one of our answers. And next, we're going to find g of f of x. In the case of g of f of x, we're going to take this function, f of x, and plug that in the place of g, in place of x here. So we say g of f of x is equal to, we replace this x here with 3x plus 2 minus 1. And we just simplify g of f of x is equal to, we have 3x and 2 minus 1 is plus 1. 3x plus 1. So in our domain, I forgot domain. Domain, no restrictions, same as for the other one. So we have a demonstration here in problem 15 that f of g of x is not the same as g of f of x. They're very close, but they're not the same. Okay, problem number 17. Find f of g of x. This time we do have a restriction. What is our domain restriction? Well, we know that x plus 1 inside this radical has to be greater than or equal to 0. So we know that x has to be greater than or equal to -1. So that's going to be our domain. I think it's probably going to be the same for both of these, unless there's something strange that happens here. I guess we can have a further restriction here on 17. But let's, I think it is going to be a little different. Okay. F of g of x. Well, there's g of x. We're going to first plug g of x in any place we see x here. So we say f of g of x is equal to, we put in parentheses here, okay, we'll put x plus 1, and that's in the play, but we square this, right? Because the x plus 1, square root of x plus 1 replace the x, but we square on the outside in -2. And so we have, when we square this out, the square root and the square cancel each other. So we have f of g of x is equal to x plus 1 minus 2. And that's going to be simply f of g of x is equal to x minus 1. And we're carrying over our original restriction. So our domain, because this has no restriction, right? We have to carry from our original restriction. We have x is greater than or equal to -1. So our domain is going to be greater than or equal to -1, comma, infinity. So even though we simplified to does not appear to have a restriction, the restriction is retained from the original evaluation of the components of this composition of functions. Next, let's go ahead and we're going to, we still have this x is greater than or equal to -1, but we're going to have f of g of x, and we're going to take this f here, this x squared minus 2, and replace this x here inside the radical. So we have g of f of x is equal to the square root of, and we're replacing this x here with x squared minus 2. So that's where that comes from. And then we still have this plus 1. And I'm going to put this x squared minus 2 in parentheses just to remind us that this is where x was replaced. And so simplifying out, we have g of f of x is equal to square root of, we have x squared minus 2 plus 1, which is going to be simplified to x squared minus 1. And in addition to the original restriction here, x is greater than or equal to -1, we also have a new restriction in this newly conceived composition functions, we know that x squared minus 1 is greater than or equal to 0, 0. And we subtract out, and when we add 1 to both sides, we have x squared is greater than or equal to 1. And when we take the square root of both sides, we're going to have x is greater than or equal to plus or minus 1, which translates to x could be greater than or equal to 1, or x is less than or equal to negative 1. So this restriction here, x is greater than or equal to 1, is the same as our original, oops. That is not the same. I was about to say something, I'm not sure. They're similar, but not the same. So anyway, we have g of f of x is this guy right here. And what is our domain going to be? Our domain is going to be greater than or equal to 1, less than or equal to negative 1. So we have negative infinity, comma, negative 1, bracket, u greater than or equal to 1, up to less than infinity. So here's our domain for g of f of x. So again, the order in the composition of functions, again, does matter. 19, we have f of x equals x squared, g of x equals the square root of quantity 1 minus x squared. We're going to find f of g of x, and to do that, we're going to take this quantity 1 minus x squared, substitute in for this x here. So f of g of x is equal to, we have square root of 1 minus x squared, and we have squared. Now, I didn't mention it yet, but we have an original domain restriction here, don't we? We know that this 1 minus x squared has to be greater than or equal to 0. And so if we take, let me see, turn this thing off accidentally. If we take, if we subtract 1 from both sides of this inequality, we have negative x squared is greater than or equal to negative 1. And if we multiply by negative 1, we're going to have x squared is less than or equal to 1, which means that we're going to have our original domain restriction is going to be between negative 1 and 1. So no matter how this works out, so f of g of x is equal to square root and squared cancel out. We have 1 minus x squared. But and this 1 minus x squared has no restriction in the domain, but we have an original restriction in the original. So we're going to have x is going to be less than or equal to plus or minus 1. So again, between negative 1 and 1. So our domain is going to be negative 1 to 1. So that's going to be 19. That's going to be this part of it. Okay, our next part is going to be plugging this f of x into x here. See? So we're going to have of g of f of x is going to be equal to square root of 1 minus, we're going to have x squared squared. So that's going to be equal to g of f of x is equal to square root of 20 minus 1 minus x to the 4th power. So that's going to be it. And our restrictions, so we have our old restrictions. We have that. If we have 1 minus x to the 4th is greater than or equal to 0, we have x to the 4th is greater than or negative 1. So you have x to the 4th is less than or equal to 1, and we take the square root of each, we end up with the same thing. So our domain is going to be greater than or equal to negative 1 all the way up to 1, including 1. Okay, let's go ahead and look at problem 21, last one we'll do in this set. We have f of g of x. We're going to take this function here, replace this, and we know that x cannot equal 0. We know that already. That's going to be, no matter what we come up with, that's going to be it pretty much. So f of g of x is going to be equal to 1 over 2. We'll have 1 over 3x, which is going to be equal to 1 divided by 2 over 3x. Well, dividing by a fraction is the same as multiplying by a reciprocal, so it's going to be equal to 1. It's going to be equal to 1 times 3x over 2. So we have 3x over 2, 3 halves x. So f of g of x equals 3x over 2. That, my friends, is 7th grade math. And so we have our domain dividing by a fraction the same as multiplying by its reciprocal. That's what I mean. We have negative infinity, 0, union, 0, comma, positive infinity. And then for this other problem, we're going to have, let me erase this so we can go the other direction. We're going to have 1 over 2x replacing this x here. So I'm going to put this in purple here. G of f of x is going to be equal to 1/3, and we replace that x with 1 over 2x, which equals 1 over 3 over 2x, which equals 1 times 2x over 3. So g of f of x is equal to 2x over 3. And our domain is going to be the same as for the other one, which is negative infinity, greater than negative infinity, less than 0, union, greater than 0, up to less than infinity. So there we have it. And we box in our correct answers. Anyway, kind of tedious maybe, but should be able to work these out. Go ahead and work on those even number problems. And I thank you for viewing.